Okay, dear students, as a part of the first BTech first sem, we have to study graphics and design modeling as one course. Here are few here. Graphics is nothing but engineering graphics. Okay, it is the one more name given to the engineering drawing. Engineering drawing and engineering graphics both are same. And here 3D modeling is included. That is the way the subject is called as the graphics and design modeling. In the engineering graphics, only 2D is there. Coming to this year, graphics and design modeling course, 2D is there as well as 3D is there. Okay, here we have to go through the conventional mode as well as we have to go through the automated. Automated mode is nothing but AutoCAD. With the help of the AutoCAD package, we have to draw the drawings, 2D drawings as well as 3D drawings. Yeah, all of you, engineering drawing and engineering graphics is a very important subject to all branches of study. Either it may be the mechanical engineering, civil engineering, electrical engineering, chemical engineering, electronics, whatever it may be the branch, we must know the fundamentals of the engineering graphics. With the help of this only one can describe the object completely with the shape and size. Okay, all of you, in the manufacturing, what we need is complete picture of the object or component. In the construction also, civil engineering construction also, complete description of the structure is required. That is nothing but size and shape and various views we need. So for that, we have to go for the principles of engineering graphics, fundamentals of engineering graphics. And here 3D is converted into 2D and 2D is also converted into 3D with the help of the AutoCAD. That is the way it is called as graphics and design modeling. Okay, before going to the course outcomes, let us go through the topics. Unit 1. All of you, as a part of the Unit 1, we have to study Introduction to Computer Aided Drawing. So before going to that, we have to go for the fundamentals of the drawing, types of lines, dimensioning, theory of projection, elements of projection, plane of projection, methods of projection. In these fundamentals, we have to go for the drawing. If you know the fundamentals of the drawing only, then we can go for the AutoCAD. So after knowing the fundamentals of the drawing, how to draw in the AutoCAD, we have to discuss. Okay, so here we have to go for the 2D drawings, two-dimensional drawing. After completion of the two-dimensional drawings, we have to go for the 3D modeling. As a part of the Unit 2, we have to study the 3D modeling. So 3D modeling using AutoCAD. So here all of you, various commands are there. With the help of that commands, we have to generate various 3D modeling objects as well as mechanical components like a pulley, like a spring, and simple assemblies we have to generate with the help of AutoCAD. So after that, we have to go for the Unit 3. So here, conversion of pictorial views into orthographic views and vice versa. What is the meaning of this? Suppose object is there, we have to convert it into front view, top view, side view. Or for the given front view, top view, side view, we have to draw the object. Okay, so that is the Unit 3. And Unit 4, projection of solids. Various solids are there, like a prism, pyramid, cone, cylinder, sphere. Here, in various positions, we have to project. We have to draw the front view, top view, and the side view. Okay, so as a part of the Unit 4, we have to study. And this one, we have to analyze and draw the views with the help of AutoCAD only. With the help of AutoCAD package only. And this one also we have to analyze and we have to draw with the help of AutoCAD package. Means this one we have to go with the AutoCAD, this one also we have to go with the AutoCAD, this one also we have to go with the AutoCAD package. And this one also with AutoCAD. And after knowing all the principles, 2D principles and 3D principles, we have to go for the simple team design project. Okay, so like that we have to, okay, like that. So it is a theory cum laboratory. Here we have 4 exercises. Here we have 6 exercises. Here we have 2 exercises plus 2 exercises. 4 exercises we have here. Here we have 2 exercises. Okay, and here one project is. So this is about the topics and exercises. So now what we have to do is we have to go to the course output. At the end of this course, means after 4 months, student can able to identify AutoCAD 2D commands. AutoCAD 2D commands. Okay, various 2D commands are there. Draw command. Okay, in the draw commands, line command will be there, circle command will be there, offset command will be there, polygon command will be there. Student can able to identify AutoCAD 2D commands with the AutoCAD package. Okay, so afterwards we have to install, and with the Zoom class, okay, we have to share the AutoCAD package and we have to demonstrate various exercises and you have to listen and you have to download the package and you have to practice like that. It will be there. Okay. So after the completion of that, what we have to do is we have to go for this. Student will get the apply skills. Okay, he can identify various 3D commands and apply to generate various 3D models. Various 3D models. Like that, he can get the identification skills, he can get the apply skills, and he can construct the simple mechanical components. Here, general mechanical components will be there. Here, simple mechanical components will be there. Okay. After identifying, he has to apply the commands to generate the 3D models and mechanical models. And then he can differentiate the orthographic and isometric projections of the various objects. Okay. Isometric means picture of the component and orthographic means front view, top view, side view, like that. Okay. So like that, he can differentiate the orthographic and isometric projections. And he can evaluate the projections of the solids in various positions. Suppose prism is there. Okay, in various positions of the prism, he can identify them. Suppose pyramid is there. In various positions of the pyramid, he can identify the views and evaluate the projection. Okay, like that, at the end of the course, he can identify various 2D commands, he can apply various 3D commands, he can construct mechanical components, he can differentiate the orthographic and isometric projections, and he can evaluate the various views of the simple solids, like with the various positions. Okay, so let us go for the introduction. So all of you, we have drawing, we know the drawing, and we know the sketching. So what is the meaning of the sketching? Sketching is nothing but it is a drawing only, but freehand drawing. Sketching is nothing but freehand drawing. Okay, all of you, like it is the freehand drawing. Suppose like a tree is there. Okay, Look, suppose sun is there like that. It is the freehand drawing. Okay, freehand drawing is nothing but sketching. So coming to the drawing, sketching is there as well as geometrical drawing is there. Geometrical drawing is there. Suppose he has to draw a rectangle like this. Geometrical drawing, rectangle like this. So we have to mention this side and we have to mention this side. Okay, what is the size of this side? What is the size of this side? We have to mention. And exactly we have to draw this. It is the horizontal line, it is the vertical line, it is the horizontal line, it is the vertical. So with simple geometrical elements, it is possible. It is possible. And here it is the free drawing. It is called as a sketching and it is called as a geometrical drawing. Okay, like that it is. So coming to the engineering drawing. So industry has to communicate the technical information to the customer. Industry has to communicate the technical information to the customers. Okay, all of you here, various uses of the technical drawings and how drawing is important to all engineering disciplines. That is the very, very important. Various uses for technical drawing. Technical drawing uses we have to know. Okay, technical drawing uses we have to know as an engineer. Okay, so all of you here, what is the purpose of this? Okay, what is the purpose of this? And which standard we have to use and which tool we have to use. Okay, all of you here, tools, we have to use various tools. Okay, in order to draw the technical drawings, we have to use the various tools. Okay, Mini Drafter will be there in the conventional drawing, and the AutoCAD package is there in the automated system. And we have to go for the various standards. We have to go for the various standards and conventions. Various rules are there. For lettering, various rules are there. And types of lines, various rules are there. And arrow marking also, various rules are there. So like that, various rules are there. We have to follow all those. We have to follow all those things. And for dimensioning also, we have to follow so many rules. And before of that, one has to know the projection techniques. If one know the projection techniques, then only he can convert the object into views, front view, top view, side view. And by knowing the standards and conventions and by knowing the tools, he can draw the front view, top view. He can draw the front view, top view, side view. All of you tools. Mini Drafter is used for the conventional and AutoCAD is used for the automated method. And here he has to know the standards and conventions. What are the standards and conventions? For lettering, standards are there, conventions are there. And for types of lines also, standards or conventions are there. And for dimensioning also, standards are there. We have to keep in mind while drawing. And here we have to know the orthographic. We have to know the orthographic principle. We have to convert the object into front view, top view, as well as side view, and we have to apply these rules. We have to apply these rules, and with the help of these tools, we have to draw. With the help of these tools, we have to draw. Okay, like that. So the industry communicates technical information. The industry communicates technical information to the customers or to the workers. Okay, workers are involving in the production of the component. Workers are involving in the production of the component. So that is the way technical information is very much important in the production of the component. And then the company has to demonstrate the various features to the customers. So in these two situations, the engineering drawing is very, very important one. Industry point of view, engineering drawing is very, very important one. Once again, listen, tools are very, very important one in order to draw. For that, what we have to do is we have to go for the conversion technique. It is the conversion technique. 3D is converted into 2D And how to draw the 2D? We have to apply the standards and we have to apply the standards. Then the industry will get the technical information that is important, because with the help of that only workers can produce the component, manufacture the component. Afterwards, the company will demonstrate the product to the customer. Okay, like that. That is the way engineering drawing is very, very important. Okay, all of you. Drawing describe any object information diagrammatically. Drawing describes any object or information diagrammatically. With the help of the diagrams, drawing can describe the object or drawing can describe the information. Okay. So all of you, suppose an object is there. An object is there. It can be represented diagrammatically. It can be represented diagrammatically. Okay, like, what is the meaning of engineering drawing or machine? Graphical means of expression of technical details without the barrier of the language. Suppose engineering component is there. Suppose a bridge is there. Suppose a dam is there. Suppose mechanical component, lathe machine is there, drilling machine is there. Without barrier of the language, okay, the drawing can tell all the features. The drawing can tell all the features. Once go through the drawing, it will tell all the information. It will give all the information. That is called as the graphical means of expression. Graphical means of expression. So that is called as the engineering drawing. That is called as engineering drawing. Suppose bearing is there. The company has to develop the bearing or produce the bearing. The worker needs the drawings of the bearing. Based on that only he can produce that component. Okay, whatever it may be, a bolt is there, a nut is there, worker needs the drawings. Based on the drawings only, the worker can produce that bolt. The worker can produce the nut like that. Okay, all of you here, diagram sketches are communication skills. Okay, this is nothing but communication. We grasp information easily. It is illustrated with diagram sketches. Okay, so all of you here. Okay, like that some component is there. Okay, all of you here, 10 diameter is there. Year to year, 12 diameter is there. Year to year, 3 mm is there. Okay, the worker will reach it. This is called as the core diameter, 10 diameter, and this is the outside diameter, that is the 12 diameter. And axial distance between the screw threads is 3 mm. Worker will read it and he can produce the component. It is a bolt actually. Okay. Okay, all of you here, it is a flight. Airbus A380. Okay, it is one of the flights. Before manufacture of it or before assemble of it, first we need the graphical model. First we need the graphical model, 3D model of it. So with the help of 3D model only, okay, the engineers will read it, the workers will read it, the manufacturing crew will read it and manufacture the components and manufacture the components and structure. As all of you here, drawings are the roadmap which show how to manufacture products and structure. Okay, all of you here, with the help of the computer graphic, we have to develop the model of a flight, and based on that we have to analyze. Okay, after the analysis we have to go for the manufacturing of. Here engineering drawing plays a vital role. Engineering drawing plays a vital role. Okay, so let us see about the importance for all branches. So here it is called as machine. It is called as one of the machine. It is called as a lathe machine. In the mechanical engineering, it is called as a lathe machine. Okay, all of you, before going to assemble this machine, the company is having hundreds of drawings. Suppose here some component is there, handle is there. For that also separate design is there, detailed drawings are there. Suppose here some component is there. For that also detailed drawing is there. Okay, so here some component is there, here some component is there, here component is there, here component is there. Hundreds of components are there. For each and every component, hundreds of drawings are there, detailed drawings are there. Detailed drawing shows size, shape, material, tolerances, it's like that, so many are there. All of you here, and the company has to produce hundreds of components, and after producing the hundreds of components based on the detailed drawing, they have to go for the assembly of machine. They have to go for the assembly of machine. So it is possible only with the help of the fundamentals of the engineering drawing or knowledge of the engineering drawing. Without of which it is not possible. Assembly of this manufacturing of this machine is not possible without the knowledge of the engineering drawing or machine drawing. Okay, like that we say, it is the application in the mechanical engineering. So many applications are there in the mechanical engineering. Bearing is there. We have to produce the bearing with the help of the drawings. Okay, spring is there. In our bike, springs are there, shock absorbers are there. We have to design the spring. Before of it, we have to go for the detailed drawing of the spring. Based on the detailed drawing of the spring only, the manufacturer will produce that component. The manufacturing person will produce that component. So here also the manufacturing person will produce the bearing based on the detailed drawing only. Okay. So all of you like that. Various mechanical engineering components are. Belt is there. If you go to the flour mill or rice mill, belt drive is there. So gear is there. Without gear, machine won't work. In order to produce a gear, detailed drawing is required. In order to produce belt drive, detailed drawing is there. Okay, so belt drive is placed over a pulley, and that pulley is placed over a shaft. Detailed drawings are there for each and every component, each and every mechanical engineering component. Based on that only, the industry will develop that component. All of you know civil engineering structure. From a small culvert to the big building is a big building. All of you, some small culvert is there. Below the road, some passage is there. This side water will go to the. Okay, there is a culvert. There also need the drawing. Civil engineering principles. Based on the civil engineering principles, we have to go for the drawings, detailed drawings. Here also based on the civil engineering principles, we have to go for the detailed drawings. Okay, elevation we need. Building elevation is a very, very important one. Building plan is a very, very important one. And the end view is also important one. In the civil engineering terminology, elevation will be there, plan will be there, end view will be there. These are possible with the help of the principles of engineering. These are possible with the help of the principles of the engineering drawing. Okay. So like that, its application is there in the civil engineering. The dam is there. Kaleshwaram Dam is there. Okay. So many bridges are there. Dams are there. Bridges are there. Buildings are. Without drawing, it is not possible. Without drawing, it is not. Dam is not possible without a drawing. Bridge is not possible without a drawing. Building is not possible without drawing. Okay. If you go to the Dubai, Burj Khalifa is there. Okay. And Burj Dubai is there. Those are all the constructions constructed with the help of the drawings, detailed drawings. Without drawing, one cannot construct those buildings or those structures. Okay, all of you here, chemical reactor is there. Chemical reactor is there, or atomic reactor is there, or steam power plant reactor, boilers will be there. So before constructing the boilers or reactors, detailed drawings are required. Based on the detailed drawings only, they will construct these reactors. Those will construct these reactors. And those will construct the pipelines. Chemical pipelines will be there. Gas pipelines will be there. Okay. ONGC will construct various reactors and pipelines. Gas pipelines will be there. So detailed drawings plays a vital role. Based on that only, detailed drawing means the size is required, shape is required, and fits and tolerances are there, as well as material required like that. We study all the things. Okay, in the drawing only, all will be mentioned clearly. Okay, all of you here. Electrical circuit. It is the electrical circuit. One has to draw the electric circuit before fabricating the circuit. Before fabricating the circuit, one must require the detailed drawing of the circuit. Based on the circuit only, has to go for the fabrication. Even a motor is there. Motor is there, circuits are there. Okay, so each and everything must be fabricated or must be manufactured or produced with the help of the detailed drawing. So that is the way there is a need to know the principles of the engineering graphics or engineering drawing. There is a need to know the principles of the engineering drawing or engineering graphics. Okay, all of you. Graphical representation of the object is nothing. Graphical representation of the object. What is the meaning of the graphical representation of the object? Suppose it is a cube represented with the help of the graphical elements. Line is a graphical element. With the help of the graphical element, the object is represented. It is a drawing. Graphical elements are there. Line is there, circle is there, arc is there, polygon is there, spline is there, like that. These are all the graphical elements. So that is the way it is called as engineering drawing as well as engineering graphics. Engineering drawing. A drawing of an object that contains all the information like actual shape, actual size, manufacturing methods, yes, which manufacturing process is required for its construction, which material is there, how many number are required, the components, each and everything is needed in the engineering drawing. Detailed drawing is there. Okay, so now we have to go for the next point. No construction or manufacturing of any engineering object is possible without engineering drawing. If engineering drawing is there, then only construction or manufacturing is possible. Without engineering drawing, construction and manufacturing is not possible. Any construction, for any construction, we need a drawing. We need a engineering drawing. Okay, engineering drawing. What is the meaning of the engineering drawing? Okay. Worked out by engineer. Engineering drawing is nothing but worked out by engineer for the engineering purpose. For the engineering purpose. With engineering principles. Engineering drawing is worked out by engineer with engineering principles for engineering purpose. For engineering purpose. Okay, all of you here, suppose the multi-purpose dam is there. You have to construct that multi-purpose. Multi-purpose means for drinking purpose, for agriculture purpose, or for power production purpose. That is called as multi-purpose irrigation well. So all of you here, engineer has to work out with the engineering principles, and it is for engineering purpose only. Power production is the engineering purpose. Power production is the engineering purpose, and canal and irrigation system engineering purpose. Okay, like so that is called as the engineering drawing. So many definitions are there. So how different from the artistic drawing? Engineering drawing is completely different from the artistic, which are used to express aesthetic, philosophical, and abstract ideas. Okay, all of you here, what is the meaning of the artistic drawing? So we can go for the aesthetics. Artist can go for the aesthetics, means look only, philosophical, and abstract ideas. Not specific. Okay, so all of you here, we can go for aesthetic look, philosophical ideas, and abstract ideas. That is called as the art. But engineering drawing is a specific calculation. Size is a must. The shape is a must. Here, we will work out the drawing for only shape. We will work out the drawing for the shape. Coming to this, here we will work out for the size and shape. That is the difference. Okay, all of you, engineering drawing. Manual drawing is there as well as CAD. Manual drawing is there as well as CAD. Okay, all of you, manual drawing with instrument, CAD with a pen. Instrument is package software. Package means software. Okay. All of you, up to now, even now also, right now also industry is using manual drawing as well as CAD. Not completely automated. So, but majority industries are using CAD package. Majority industries are using CAD package. Why we have to go for that CAD? So, but before using the CAD package, one must to know the principles of the manual drawing. Then only you can easily use the CAD package. Then only you can easily use the CAD package. Once practicing the manual drawing, okay, you can switch over to the AutoCAD very easy. AutoCAD very easy. Okay. So all of you here. So with this, time is more. Time required is more. Accuracy is less. Okay. So with CAD, less time is needed. More accurate. More accurate. So that is the difference between these two. And here, productivity is more. If these two are there automatically, one can go for the so many drawings in the stipulated time. Here, productivity is less. It takes a lot of time. So automatically, productivity will be ready. So here, manual drawing. What are the instruments required for the manual drawing? Okay. So all of you here, our laboratory is handling with the help of the AutoCAD package only, but how manual drawing is going on, let us go for that. How manual drawing is going on, let us go for that. So items required for the drawing. Okay, items required for the drawing. So drawing board is required, drawing sheet is required, mini drafter is required, instruments compass, divider, scale is required, protractor is required, pencil curve is required, drawing pencil, eraser, drawing clip and pin is required, sharpener is required, as well as duster is also required. Like that, these many are required. These many are required for the manual drawing. Manual. Okay, I'll have you drawing board. On the drawing board, you have to place the drawing sheet with the help of the drawing clips. Okay, drawing clips are pins. This you take. Drawing board is there. On the drawing board, we have to set the drawing sheet and attach it to the drawing board with the help of the drawing clip or pin or adhesive tape. Okay, like that. So after that, mini drafter, we have to fix the mini drafter in order to get the parallel lines, in order to get the perpendicular lines, in order to get the inclined lines. We have to go for the mini drafter. It is a drafting machine. Next, instrumentation box. Compass will be there to draw the arcs, divider will be there, scale and protractor is required for the angle measurement. French curves are required to draw the curves, and drawing pencils are required to draw the object or to draw the drawings. Diagrams, eraser is required, and sharpener is required, drafter is required. These many things are required in the annual drawing. These many required in the annual drawing. Okay, so let us see about this. Drawing board must be placed on the table with working edge always to be at the left side. This is the one. This is the working edge. Left side is the working edge. And this is the drawing board placed on the table. It is the mini drafter. It is the mini drafter. We have to place this at the left side, top corner of the table. It is called as U-clip or clamp. U-clip or clamp. And these are the links of the drafting machine and scale. This is the scale. We have to tighten here and we have to tighten here. Okay. So here we have to place this edge here in order to get the horizontal. And afterwards we have to tighten here and you can rotate like this or you can rotate like this. Whatever it may be, it becomes the horizontal and it becomes the vertical. Automatically, if you draw with the help of this, it is the horizontal or vertical line anywhere with the help of this. Like the parallelism and perpendicularism is parallelism and perpendicularity is maintained with the help of that mini drafter. And suppose you can rotate this to the particular angle and you have to tighten. You draw a line like this and parallel line you can draw this, parallel line you can draw this. Here it is tightened, here it is tightened. Here, there is no disturbance in the parallelism. There is no disturbance in the parallelism. Like that, it means it is called as drafting machine. It is called as a mini drafter is a miniature version of the drafting. Mini drafter is the small version, a simple version of the drafting machine. Please see here. Please see here. It is the table. On the table, board is placed, drawing board is placed, and here U clamp is placed like this, and tighten it is tightened, and it is the link, and here also it is tightened. Automatically, it will not slide. It will not slide. You will get the horizontal line anywhere, or you will get the vertical line anywhere. After tightening, automatically you will maintain parallelism and perpendicular. So this is the table, board, and drafting machine and the drawing sheet. And these are the clips. Here clip is there, here clip is there, here clip is there, like that. And here there is no need of the clip. These are the various drawing clips. Okay, with the help of these clips only, one can attach the drawing sheet to the table. You see, French curve. These are the French curve. These are also French curve. This is also French curve. And you see protractor, 180 degrees protractor and 360 degree protractor. And here French curves are there, as well as set square is there here. Set square. 45 degrees set square and 30 degrees 60 degrees set square. And French curves are there. Like that, these are the important instruments. Anyhow, this one and this one is possible even with the help of the mini tractor. Why? Because with the help of the mini tractor, one can go for the angle. One can go for the angle. Angle markings will be there on the mini tractor. Angle markings are there on the mini tractor. So like that, these are the important. Where angle markings are there, you know. Here itself only angle mark. Here itself, suppose 0, this side 90 degrees will be there, this side 90 degrees will be there. You can rotate this one in this direction or you can rotate this one. Suppose you need a line like this, you have to rotate like this. You need a line like this, you have to rotate like this. It is all about the manual drawing. It is all about the manual drawing. So here designations will be there. You know A4 paper. You know A4 paper very trimmed size, untrimmed with borders. It is with borders, it is without borders. With borders, the size. All of you, A4 210 to 297. A4 is 210 to 297. So horizontal is 210 and vertical is 297. It is in mm. It is in mm. Okay, all of you, here it is 210, 29, like that. Okay, so like that we have to go. And A3, it is nothing but A3. 297 and 420. 297 and 420. Like that it is there. Okay, how to get that? You know, this 297, this 297. Same, but 210, 210, 420 is double. 420 is double. Okay, like that. If you go to the A2, 420, 420 is same, and 297, 594 double. Okay, like that is there. Then A1, 594, 594 is same, but okay, like that we have to go. 420, 420 is double approximately. Okay, now 841, 841 same. This one, okay, like that is there. We have to know this as per the Bureau of International Standards. BIS is nothing but Bureau of International Standards. Okay, likewise, yeah, how to get that? It is the A4. It is the A4. Okay, all of you. Now, what we have to do is how to get the A3. How to get the A3. So here it is the 210 and it is the 290. This 297 is the common. 297 is the common. But how to get this? We add one more A4. So this becomes 420. This becomes 420. Okay, now automatically this becomes A3. Now you double this, automatically you will get A2, and you double this, automatically you will get A1, and automatically you will get A2. Like that will be. So from here you will get A4 is converted into A3. Now A3 is converted into A2. A2 is converted into A1. A1 is converted into A0. Like that it is there. It is the A4 specification, A3 specification, A2 specification, A1 specification, A0. Okay, like that it is there. One has to remember like that. Okay. After knowing this, we have to go for. So it is the layout of a drawing sheet. Just to see here, layout of the drawing. So here border is coming like this. This is the border. This is the border, and here title block is there. For that also dimensions are there. And here how much gap to be maintained from here to here. Okay, and trimmed edges, borders, like that. All the rules are there here. All are specified here in the title block. The component related details will be mentioned. And here one has to go for the drawing. Okay, one has to go for the drawing. Suppose we have to draw like this. Some object is there, we have to draw like this. We have to draw like this. We have to draw the views like this. Okay, we have to draw the views like this. Suppose it may be the front view, it may be the top view, and it may be the side view, like that. One has to draw like that. So these are the specifications related to the layout of a drawing sheet. So these are the drawing pencils. So pencil related rules also there. Wooden pencils are there. Graded and designated members. Mechanical flat pencil is not allowed actually in the drawing. Okay. B is there. Decreasing order of the softness and the blackness. Okay, all of you. 7B is there. It is the dark one and a soft one. It is not dark one, it is not soft one. Hot one. B is the hard one. 7B is the soft one. And HB is there, F is there. It is a medium grade. And H, 2H, 3H, increasing order of hardness. Okay. Now you see here, B grade, not in B grade, in H grade, increasing order is there of the hardness. H is the soft, and 9H is the hard. 9H is the hard. Like drawing are done using 2H pencil. All of you please see 2H pencil. Initially, we have to construct the drawing with 2H pencil and finish it with H pencil or HB pencil. H pencil or HB pencil. Okay. Initially, drawing should be worked out with 2H. With the help of the 2H, one will get the very light lines, and afterwards, we have to pick the important lines or important features with HB pencil or HB pencil or H pencil. Okay, like that. So different types of lines. Different types of lines. Okay. In order to go for that, suppose object is there. Suppose object is there. That object is represented with the help of a thick line. Object is represented with the help of a thick line. Okay. Now, thin line. Suppose thin line is used for the dimension line, extension line, section line, and construction line. So these are the extension lines. This is the dimension line, and we have to mention the dimension line. It is the thick line and it is the thin line. It is the thick line and it is the thin line. Thick line is used for the outlines or visible outlines, and thin line is used for the dimension line. And continuous thin wavy. Short break lines are irregular boundary lines. Irregular boundary lines drawn with a free hand, like that is it. And continuous thin with a jog, long break lines are to suppose 100 meters we have to represent. Like we have to break and we have to represent it as 100 meters long. It is difficult to represent on the drawing board. That is the way we have to go for the long break line. Short dashes. Suppose invisible is there. Okay, so all of you here a hole is there. And further, if you see from top that is not visible, invisible, we have to represent with the help of the dashes. We have to represent with the help of the dashes. Okay, short dashes. Short dashes. Invisible or interior surfaces. Okay, so now we have to go for the short dashes like this, center line. Okay, or locus lines like this, or long line, short line like this is called as a long line, short. Okay, long line, short, long line, short, long line, short. It is used for the center line. So all of you here long line, short line, long line, short line, long line, short line used for the center line. And long line, short line, long line, short line, long line, short line. And picket ends, it is used for the section. Cutting plane will be there. Cutting plane lines will be there. For that we have to go. So in the drawing, one has to represent the way. One has to represent various things. Yeah, I will explain. Here one component is there. Like this. And it is having hole here, it is having hole. This is the front view of the observer, front view direction for the observer. And it is the top view direction for the observer. And so this is the front surface. He has to project the front surface. He has to project the front surface. All of you, we will get this. And here hole will come. But here this will not appear, this hole will not appear. That is the way he has to go for the dash. And the center of the holes he has to represent. Okay, like that. And similarly he has to go for the top. This will be visible, this will be visible, and this surface will be. He has to draw this. Okay, and he has to draw this, and he has to draw this. And here hole is visible, hole is, and here section, this part is section. This part is section. That is the way it is like the section lines also represented like this. So if you go through this, all the lines are represented here. If you go through this, All the lines are represented here legal. Okay, all of you here, this is the continuous line, outline. It is the outline that is the way continuous. It is the cutting plane line, cutting taking place, long line, short line, long line, short line, and thicket ends. Just now we discussed. Hidden lines, holes are invisible, represented with the dashes, are represented with dashes, like that it is there. And it is the center line. Center line is represented like, all are represented like that. So here, the knowledge of the types of lines is very important. The knowledge of the types of line is very, very important part. Okay. Here, this is the dimension. Here it is the dimension. It is the extension line. Like that, so many lines are there. Like that, so many lines are there. So all of you here, dashed lines are used to represent hidden features of the. Wherever invisible or hidden features are there, we have to go. All of you, we are discussing about the dash lines. Dash lines, drilled out hole is there. Suppose that for the drilled out hole, the material is coming. So automatically it will be hidden. Those hidden holes are represented with the help of dash. All of you here, here hole is there, but it is not visible. In the top, it is not. It is in the front, it is visible, and in the top, it is not visible. Hidden lines are there. Dashed lines represented with the help of the dash. Next, lettering. Coming to the lettering. Lettering is used to write titles, dimensions, and other necessary information on a drawing. So on the drawing sheet, lettering is the important one. We have to mention that 30, 40 like that, and all dimensions are in mm. We have to write, and the details of the front view or object, the details of the top view of the object. We have to write all the things on the drawing sheet. That is called as a letter. Okay. So 2H pencil is preferred for the lettering. Okay. Or HB pencil is preferred for the lettering. The lettering should be done in such a manner that it should take minimum time without the use of the drawing instrument. Without use of the drawing instrument, freehand only we have to go for the lettering. So here, single stroke letter will be there, vertical letter will be there. Single stroke letter will be there, vertical letter will be there. What is the meaning of the single stroke? With one stroke, the letter has to come, and it should be. In the engineering drawing, we have to follow. In the engineering drawing, we have to follow. In the single stroke, and it should be. It should be vertical. Okay, like that lettering should be. Ellipse We have to write like this. Okay, this height is the very important. Height is the very important one. Okay, so 3 mm height is used for the notes. Suppose subtitles are there, we have to go for the 6 mm. Okay, and titles are there, we have to go for the 8 mm height. 8 mm height, and height to width ratio will be 6:5. Height to width ratio will be 6:5. Like that, while lettering. Okay, all of you here, few standards related to the drawing. No effective communication without an agreed upon the standard of speakers. Agreed standards we have to use. Without of it, no effective communication is there. If you use effective communication, it is possible only with the help of the agreed standards. Okay? Standards and conventions and the alphabet of technical drawing and plain, solid, and descriptive geometry are the grammar which underlines the graphics language. Okay, technical drawings and plain, solids, and descriptive geometry. These are all the alphabets of the technical drawing are nothing but plain, solids, and descriptive geometry. All these are the alphabets of the technical drawing. Following the standard rules of any language, we have to follow the standard. For Hindi also we have to follow the standard grammar. For the English also we have to follow the standard grammar. Like here grammar is there in planes, solids, descriptive geometry, and type of lettering, and type of dimensioning, type of line. Like that we have to follow all the standards and conventions. Okay. Communication of thought between people becomes easier. If you mention clearly the drawing, the communication is possible between the people. If it is not, okay, if words in a sentence were present randomly, understanding becomes very difficult. Suppose construction of the sentence is there, in that the words are presented randomly, understanding becomes very difficult. For effective communication of the for effective communication of technical information, set of standards and conventions. Okay. So next we have to go for the dimension. What is the meaning of the dimension? We have to go for the length. We have to go for the width. We have to go for the height. We have to go for the diameter of the holes and the location of the holes on the drawing sheet of the particular object that is called. Drawings are dimensioned using an accepted set of standards such as placing the dimension such that it is read from the bottom of the sheet. And we have to read from the bottom of the sheet. Okay. So all of you like this. Suppose the drawing is a 70, we have to from the bottom we have to follow the rule. So representation of the width, representation of the height, representation of thickness, representation of the diameter of the holes, and representation of the hole location of the object on the drawing sheet is called as the dimension. And dimension must be placed from the bottom. Okay, all of you here, you can see how the dimension is placed. 75 dimension, like 1.25, 1.00, it is 0.07, sorry, 0.75. Okay, like that. It is the 0.5, like that. It is the 1.5, it is the 2.0, like that. The drawings, detailed drawings are mentioned. Okay, all of you. Holes location, it is the correct. One can go for the distance between the holes here only, not. It is the front view, suppose, and it is the top view. Here itself only you have to represent, not. Okay, so it is the correct representation. We have to follow all these rules. All of you here, we have to mention the dimension here. It is the best. Here also it is okay, but it is not. But it is not. Okay, like so all of you here, you see the dimension here. Dimension is there. Here dimension is there. Here dimension is there. If you place the dimension one above the other, it is a good practice. If you place the dimension like this, it is a better practice or preferred practice. Okay, all of you, dimensions must be read from the bottom. Dimensions must be read from the bottom. All dimensions and values must be read from the bottom as 75, 40, 15. Okay, like that. And must be from the right, from the bottom and from the right. And like that here, from the bottom only. This is from the bottom, this is from the bottom, this is from the bottom. Like that. Okay, arrows. Okay, all of you, the dimension should be terminated like here, arrow head must be there. Here to here, it is the it is the 3, and here to here it is the 3:1 ratio must be maintained in the arrowhead. 3 mm wide end should be 1/3 as a wide. They are long. Symbol placed at the end of the dimension lines to show the limits of the dimension. Arrows are uniform in size and style regardless of the size of the drawing. This is the practice of arrow. It is completely closed or filled. It is unfilled. It is open arrow like open arrow. Okay, closed arrow but unfilled. One can follow this one or one can follow this one or one can follow. All of you here, various basic geometric entities are there. These are the angle, the right angle, various triangles, various polygons, and the final one is the circle and prism, cube. Okay, it is the solid, it is also solid, various solids. These are all the geometric entities. These are all the a cone is represented here and cylinder is represented here. Okay, like that, various truncated, okay, cone is there here, truncated cone is there. Okay, like that, so many are there. So many are there here. These are all the geometric entities. These are required in the drawing. These are required in the drawing. Okay, now that is the manual. Now coming to this AutoCAD. Okay. So all of you here, one can go to the AutoCAD and you type line command will come and you give the information, automatically line will be generated. Again give the information, line will be generated. Again line will generate, line will generate, line will generate. And then what we have to afterwards, we have to go for the chamfer of this, after you go for the circle of this, and after you go for the circle of this. So automatic, and again we have to go for the line like this and chamfer of this. Again here we have to go for the circle, we have to go automatically, this will be generated in the 2D drawing. Is the 2D drawing. And now how a 3D drawing is generated with the help of the AutoCAD. It is difficult to draw with the help of the manual drawing, manual method. Okay, but with the help of the AutoCAD, one can go like just you revolve it by 360 degrees, automatically this object will be generated. This object will be generated automatically. So like that, with the AutoCAD, one can go for the 2D drawings or one can go for the 3D drawings very easily. You see here, with the help of the AutoCAD only, we are getting the 3D object. So it is a one more 3D object. Just 2D is converted into 3D. With the help of the command. Command is called as the extrude command. Extrude command. Okay, like that. You see how a spring is generated with the help of the AutoCAD. It's equal to draw with manual method, but with automated method, it is used one object. Okay, so how springs are generated here with the help of the AutoCAD. Okay, so this is about the lesson 1, fundamentals of the drawing and the applications of the drawing, and how this engineering drawing helps in various things. What are the methods? Manual method is there, automated method is there, and in the manual method, what are the various tools are required? In the automated method, what are the various tools are required? And we studied the fundamentals. We studied the fundamentals, and we studied the standards and all of it. Okay. We will see the few more topics in the next session. Okay. Thank you, one and all.